Alrighty, guys, this is the back of your pickup of 3.3, day 1 of 1. I need you to go ahead and read this if you have not already, and make sure to take notes and take down anything that you think is important. So go ahead and pause this video, give this a read right about now. Okay, so let's take a look at example 5. I hope you pause that, give that a read if you haven't already. So there's a part A and a part B, so it's going to take us a little bit time to go through, but I want to make sure that we keep that separate. So the first thing I like to do with these problems is I like to write down, first off, the shape. So it says an oiler tanker spills oil that spreads in a circular pattern. Okay, so that word circular means that I'm dealing with a circle. Circle. Right? Okay. Then I like to write down what I am given. Okay? What I am given. So it says the radius increases at the rate of 50 feet per minute. Okay. If the radius is changing at a rate, we should be thinking derivative. So that means that dr dt is what they gave us. And it said it's increasing 50 feet per minute. So 50 feet per minute is what they give us. It says, how fast are both the circumference and the area of the spill increasing when the radius of the spill is, okay, so this is another thing they give us. When the radius for part A, when r equals 20 feet, but then part B, we want to know when the radius equals 50 feet, okay? So that's what's given. Then it's important to write down what you need to find, okay? Because if you don't know what you need to find, you're going to be in some trouble. How fast are both the circumference and the area of the spill increasing? All right, so increasing means that the circumference and the area are changing, right? So that means we're looking for dc dt, and we're also looking for dA dt, okay? Those are the two things that we need to find. And then the last piece are the equations. It's going to be really helpful to write down the equations you need to use, okay? So if I'm looking for dc dt, that's the change in circumference. So I definitely need the circumference formula to get me started, okay? And then I'm just going to go ahead and take that derivative, right? Because that's what's going to give me dc dt. So dc dt, and this is what we were doing before. And then the derivative of 2 pi r, it's just power rule, so it's 2 pi, but with respect to time, so dr dt. Okay, so that's the first important formula we're going to need. And then the next one is going to be our area. And again, this is a circle. So our area of our circle is going to be pi r squared. And we want to take the derivative of that. So with respect to time. So dA dt is going to be, and again, power rule 2 pi r, but with respect to time, so dr dt, okay? And so now we have pretty much everything that we need to solve this problem, okay? So let's start with part A. Let's do part A, okay? We want to figure out how fast the circumference. So let's find dc first. So if I know that dc dt equals this formula right here, right? 2 pi dr dt, okay? All you have to do is plug in, right? So they gave us dr dt. So these problems actually become a lot more simple once you write all this stuff out, okay? So dc dt, when our radius is 20, well, r isn't in here, so I don't even have to worry about that. It's just going to be 2 pi, and then dr dt is 50, right? So I know that my dc dt is going to be 100 pi, and that is going to be in feet per minute. Not so bad. And then we can do that same thing for our area, right? But now we have an r. So our dA dt, and I'm not going to write the formula out because it's right here, is going to be 2 pi, and our r in part A is 20, okay? And our dr dt is 50, okay? So that's going to give us 2,000 pi feet per minute as our dA dt, okay? And so that's going to, repeat. That's exactly what we're going to do for part B. Now, the only thing that's different is our r is 50 feet. But like I said before, for dc dt, there is no r in the formula. When we took the derivative, it went away, okay? So it's just going to be 2 pi, again, times dr dt. Well, dr dt is still 50 feet per minute. So it seems that this rate did not change, which is totally fine. Okay. Oh, I forgot the pi. Sorry. And then our dA dt will be slightly different because we have an r. So 2 pi r dr dt. So 2 pi, and it says part B, the radius is 50. So times 50, and then our dr dt is also 50. Okay, from original information. So this leaves us with part B of a dA dt being 5,000 pi feet per min. Cool. Alrighty. Example 5.